Tajin mooring lines, the myths unraveled. The impact of temperature on mooring lines. Mooring lines, essential equipment for any vessel. For a long time, steel mooring lines were the standard solution for securing ships to permanent port positions. However, in recent years, synthetic mooring lines have become established alternatives. The low weight, the absence of rust and sparks, and the easy handling and high strength provide a durable and attractive substitute. But regardless of which high-performance or synthetic fiber is used, safety must always come first. Because when a mooring line breaks, the results can be lethal. Mooring line accidents have to stop now. How can we be sure we're choosing the right product for the right environment? Offering us a helping hand is Matt.
So knowing that safety and durability in mooring lines is of absolute importance, how do we choose the right product for the right environment? Whilst performance tests tend to be carried out in lab conditions, assuming that the whole world is 21 degrees with the occasional drop of rain, the true day-to-day environment appears to be very different.
Like here, in Port Hedland, Western Australia, where the sun is beating down hard. To show you the alarming differences in temperature on ship, we have carried out a test using a thermometer. As you can see, for mooring lines lying in the sun, the temperature easily rises 15 to 20 degrees.
How will our different mooring line materials really hold up under true life conditions? Today, we're about to find out. To help us perform these tests, we enlisted the help of the Technical University of Delft. Research students Lars and Esme performed a couple of tests for us, the dynamic rope test and the yarn test. And to help me explain the difference and the reason for conducting these tests, I've found my own R&D specialist and expert in mooring performance, Tony Matthews.
Test 1. The dynamic rope test. The performance of a rope is influenced by the temperature outside and inside of the rope. When a rope is moving during an application, the temperature inside the rope increases. We can demonstrate this by undertaking a dynamic rope test.
In this particular test, an aramid rope is loaded onto this machine and where it is moving over a sheave. The temperature outside of the rope is measured by means of an infrared thermometer. And you can clearly see the temperature is increasing outside. And this increase in the temperature is caused by the heat development inside of the rope.
As we can see, the core does get very hot.
I imagine all this heat heavily affects the performance of these synthetic lines.
That's correct. In fact, there is a relationship connecting the core temperature of the rope and what you measure on the outside of the rope. Simply said, thicker the rope, hotter it becomes inside.
Okay, so if I've got this right, the inside of the rope gets much hotter than the outside.
That's correct.
Okay, and what effect does this have on the rope?
It has a significant influence on the performance of the rope material. And we can demonstrate that by means of two simple tests.
Perfect, so let's see the results.
Test 2. The yarn-to-yarn test. In this yarn-to-yarn or strand-to-strand contact test, we compare the performance of an aramid and an HMPE yarn at higher temperatures. The rubbing together of the yarns simulates the movements inside a rope.
As you clearly see, HMPE is failing and aramid is intact under the influence of elevated temperatures.
Test 3. The strength test. In this test, we compare the strength of an aramid and HMPE yarn at room temperature and also at about 70 degrees Celsius.
From the results, you clearly see that aramid is intact at 70 degrees Celsius and HMPE reduces its strength already at 70 degrees Celsius.
That's a significant difference.
Indeed.
Imagine this happening on a fully functioning ship. Quite a safety hazard for the crew.
Both these materials, HMPE and aramid, are great options for the mooring line application. However, When your ship is moving around the world and the deck is exposed to higher temperatures, aramid-based mooring lines offer you a safer and durable mooring performance.
And there it is. The difference between room temperature lab tests and true working environments has a huge impact on the mooring line performance, safety and durability. This myth is officially busted.
Working with mooring lines all over the world requires the right equipment. It needs to be safe and reliable wherever you are and whatever the weather conditions. Which mooring line suits your vessel best?